All right, here is part 2 of we're finding the area of a regular polygon. And we're going to look for the apothem on this one. Now this is a bit complex. We're going to have to figure out, okay, we got to come up with our central angle and a whole bunch of other things. So here we have another hexagon, which is very easy to work with because it gives us a special right triangle. So we have our center of our circle right here, and which is the center of our polygon. Then we find our central angle. That is the very next step. Now the central angle is nothing more than the number of sides divided into 360. So we have 360 over 6 is equal to 60 degrees. So this angle right here is 60 degrees. This whole thing, 60 degrees. Since this bisects, each one of these is 30. So that's 30 and that's 30. And we know this is a right angle. So that, my thing doesn't work all the time. So that's 60 and this is 60. And we have a 30, 60, 90 special right triangle. Works really good for hexagons. So let's take a look at an example. Here we have a hexagon here. We have 6 sides, 1, 2, 3, 4, 5, 6. And we have our center of our circle, which is the center of our polygon right here. And we have a side length of 14, so all these are 14. Now since this bisects, this side is 7 right here. This part right here is 7. Our central angle, which we just talked about, is going to be 60 degrees. Let me write that for you again. So it's just 360 over the number of sides, which is equal to 60. So this whole thing right here is 60 degrees. That means this is 30 and this is 30. And this over here is 60. And the one reason why hexagons works really, really good is because you have basically not only a 30, 60, 90 right, but you also have an equal angular, equilateral triangle as far as your 6 triangles go inside this hexagon. So we can take a lot of shortcuts here. But what we're going to do right now is we're going to draw, I'm going to come over here and draw my 30, 60, 90. So this is my 30. This is my 60, and this is my 90, and this side is 7. If you remember on your special rights, and it's on your EOC formula charts, opposite my 30 is A, opposite my 60 is A radical 3. All right? So this side right here is 7 radical 3. So we have 7 radical 3 as my apothem, little a. Okay? So 7 radical 3. And this radius is going to be 2a, which is going to be 14, which is because it's equal angular and equilateral on a hexagon, your radius is going to equal to your side. Okay, so now we just plug it into the formula. 1/2 apothem times perimeter. So my apothem is 7 radical 3, so I have 1/2 times 7 radical 3 times... let's see, we got 6 of these, 60 plus 24 is 84. So my perimeter is 84. And I'm going to put that in the calculator real quick. I'm going to use 0.5. 0.5 times 7 shift radical 2. I could, if I'm doing approximate, I could put this into a decimal. And then times 84. And that'll give me my area. 415.78. Sounds good to me. All right. Alrighty, so moving on. Well, let me write that down for you. 415.78. I round to the nearest hundreds. Do this on your own. Pause, redo it. Now, an octagon, 9 sides. This is not going to be a special right triangle. So let's go ahead and find my central angle right here. Let's find this. That's just 360 over 9. So 360 over 9 is going to give me 40. So my central angle is equal to 40. This right here is 40 degrees. So this right here, my apothem, is going to bisect it. So this is going to be 20. This is going to be 70. This side is going to be 5. So I redrew the triangle over here. So this side is 5. I have 20. And I have 70. Now given a right triangle, with a side and an angle, you can solve it using either special right triangles or trig. Well, we're going to have to use trig. And it doesn't matter what angle I use. It looks like it's going to be tangent either way. So I'm going to have opposite over, we're going to solve for this side right here. I'll call this side x. All right. We're going to have opposite and adjacent if we're using the 20. And if we're using the 70, we're going to have adjacent and opposite over here. So we have our 20, 70, 90 right triangle. We're going to solve for x, and it looks like it's going to be tangent. And that's the only way that we really can solve this. I'm going to use the tangent of 20. Tangent of 20 is equal to opposite over adjacent. When we use our algebra, basically those switch places because the x is in the bottom. And we have 5 divided by tangent of 20 is going to equal to my x. And let's put that in the calculator. So we come over here, 5 divided by tangent 20 gives me 13.74. 13.74 is going to be my apothem. 13.74 is my apothem. All right. And I could have done the same thing with tangent 70. I mean, watch this. It'd be tangent 70 is equal to opposite over adjacent. So what we're going to do is 5 tan 70 will give me the same thing. Okay? So it didn't matter which angle you used. You have to use one of your acute angles. You can never use your right angle. 1/2 apothem times perimeter. My perimeter is 90 because there's 9 sides and I chose an easy number on purpose. So I'm going to do 1/2 times my apothem, 13.74, times 90. And that's going to give me some number. So I'm going to use 0.5 for a half again, times 13.74 times 90. And 618.3. 618.3 is my area in whatever units we're using. Okay, so that is pretty much it. And I will get these uploaded probably Sunday. I'll wait a few days. All right.